Okay, guys, so let's take a look what section 7.4 is all about. Maybe, there we go. So all chapter we've been talking about confidence intervals. We have found the confidence interval for the mean when we know the population standard deviation. We found confidence intervals for the mean when we don't know population standard deviation, and we have to use the sample standard deviation instead. In section 7.3, we will look at confidence intervals for a proportion, but again, we're going to switch up the order because this section I feel is going to need more of your attention than 7.3, so I want to give you the most time before the test with this one. So when we're finding confidence intervals for variances and standard deviations, maybe, there we go. We use a different distribution. It's called the chi-square distribution. There we go. The chi-square distribution, and in just a minute my animation will pop up and it'll have the symbol there. It's already on your sheet. It's pronounced chi-square, not chi-square, and it looks like chi, but it's a chi-square distribution. Just like we saw with our t-distribution, it is a family of curves, and we once again see that idea of it being based on the degrees of freedom. Remember, degrees of freedom is just symbolized df, and it's just your sample size minus 1. In section 2, we saw the example where we had the 10 data values that gave us that specific mean of 50. 9 of those values were free to vary. The 10th one we had to have locked in, so we got our mean of 50. So again, we've got that family of curves, degrees of freedom. Another very important characteristic, the chi-square variable cannot be negative. The chi-square variable cannot be negative. That's super important for us to know, because if you're working with it and you come up with a negative, something's not right. So that's going to be a big red flag to you. If you work through any of our formula pieces and you end up with a chi-square and it's negative, something didn't go right for you. The distributions, we're going to want to sometimes, not this section necessarily, but in the future we're going to see chi-square again, and we're going to want to actually sketch out the distribution. When we sketch that out, we have to keep in mind that that is a positively skewed distribution. So that means you can see little pictures down at the bottom of several of the curves. Remember, if it's positively skewed, aka right skewed, a bulk of our data is going to be over on the left, and then it just kind of trails off. It's skewed towards the right. So there's a few data values that it's kind of pulling your graph a little bit to the right, but a bulk of your data is to the left. At about 100 degrees of freedom, and most of the stuff we work with, our sample sizes are smaller than that, but if we get to about 100 degrees of freedom, the distribution does become somewhat symmetric. And if you kind of see, I do have the little figure on your handout there. You have degrees of freedom 1, and then there's 4, and then there's 9, then there's 15. So as the degrees of freedom are increasing, you slowly do start to see that curve slowly creeping towards becoming symmetric. It's slowly getting there. One last idea for our chi-square distribution, and then now my beautiful symbol finally popped up. It's already on your sheet. The area under the distribution, we're still looking at that 1 or 100%. So just because it doesn't travel into the negatives like our standard normal and our t-distributions, that's okay. The area under that curve is still 1 or 100%. That's not going to change. We will see chi-square in future chapters as well. You might not see the need for these characteristics today, but I wanted to present them to you today because it is a new distribution for us, one that we will be using. But in future chapters, we're going to need to know these things. We're going to be sketching out the graphs of our distribution. So I just wanted you guys to see these characteristics today, introduce it today. We're going to be using these characteristics a little bit more in our future chapters, and we will bring them back up again. The symbol finally popped up for me. I apologize for my not great animations there. It looks kind of like a fancy capital X and then it's squared. It looks kind of like a fancy capital X, kind of like a cursive one, I guess you could say, and then it is squared. So, what do we need this distribution for? We need our distribution, we need to find two values. There's a chi-square right, and there's a chi-square left. The right and left are just little subscripts. We need two different values this time, not just one. We've had z sub alpha over 2 and we've had t sub alpha over 2. Now we have a chi-square right and a chi-square left. Remember, our graph is not symmetric. So remember, we had z sub alpha over 2, maybe we had 1.96. Well, we had negative 1.96 on the left of the distribution, we had positive 1.96 on the right. These graphs are not symmetric. So now we do need two different values. We have a chi-square left and a chi-square right. Table G, it says it's on page 791 in your book. It's also on, if you want to grab it out, it's also on the handout I printed you that had table F on it as well, if you don't want to have to flip to the back of your book. I just want to talk to you specifically how to find the chi-square right and left using that table. We'll talk about the formula a little bit. We'll do an example. I'll get you guys some time to work. All right, so in order to find these two values, the first thing we have to do is find alpha over 2. That's not going to change for us how we found it with z sub alpha over 2. Alpha is still 1 minus our confidence level, and then we divide it by 2. This is the column on the right side of the table that we will use to get chi-square right. So I'm going to go through the steps with you. We're going to talk about the formula a little bit, and then we're going to put everything into action. So we do need to find alpha over 2. We're going to use that on the right side to get chi-square right. Whoop, not great animations again. Sorry, guys. Then we need to subtract alpha over 2 from 1 to get the value used on the left side of the table to get chi-square left. So remember, it's not going to be as easy as z sub alpha over 2 simply because our graph isn't symmetric. When our graph was symmetric, we could find the negative z sub alpha over 2 on the left, and then the right, well, it's just the positive of that number. Or vice versa, you could find the positive on the right and the negative is the same space on the left. All right, then once we have those, we find the appropriate row corresponding to the degrees of freedom. So we've got our n minus 1 we see for degrees of freedom. And then we'll also take a look at this when we get to table G. It says if the number of degrees of freedom is not given in the table, use the closest lower value in the table. So I just want to make sure, I know this is all filled in on your sheet, but you're using the closest lower value. So if my degrees of freedom is 57, and I only have a choice between 50 and 60, I'm going to go with 50. You always go lower on the table. And we'll take a look at that. We will look at table G. I'll bring it up on my screen in just a minute for you. When we're finding those confidence intervals, and I know this part is already filled in on your sheet for you, but it's something that I want to make sure we talk about, and I wanted to make sure you had it on your sheet. When you're finding confidence intervals for variances and standard deviations, you must assume the variable is normally distributed. S squared, you're going to see S squared in the formula. I just want to make sure we hit on these symbols again. I know I assessed you on them last chapter. I just want to make sure we keep bringing it back. S squared sample variance. S, just little plain old S, is your sample standard deviation. So let's make sure we talk about the relationship between the two. And then we're going to dig into the formula. We'll do an example and get you guys some time to practice. If you are given the sample standard deviation, you're going to have to square it when using the formula. The formula has S squared in it. If you are given the sample variance, you don't square it. You don't square it. So here's the formula. You guys already have it on your sheet. S squared, this is the sample variance. It's what we just refreshed on that last slide. S squared is your sample variance. So if you are given the sample variance, you just put it right in the formula. I do nothing to it. If you're given sample standard deviation, you put it in for S, and it has to be squared. So you have to be really careful. I would say with this formula, that's one of the common mistakes that I'll see. S squared, the S and squared together is the symbol for sample variance. So if you are given sample variance, that value replaces the S squared, all of it. If you're given sample standard deviation, that just gets put in for the S, and then you still have to square. So here's where knowing those symbols is absolutely necessary for us if we're going to be successful with this formula. So this is the formula for variance. Now the nice thing is, standard deviation, guys, it's the same thing except we take the square root. So that relationship is still there. The standard deviation is just the square root of the variance. That's all it is. So it's not really two separate formulas. We're just taking the square root of one. Okay. Rounding rules. Raw data. I just want to make sure I hit on this again. I continually am still getting questions on this when you guys are doing your practice. So I wanted to hit on this one more time. If you're given raw data we've worked with the last couple lessons, that's when you are given, if it's a sample size of 30, you are given all 30 data values. You are given all 30 data values. You know the raw data. You know that sample data. Go one more decimal place than the original data. If you are given, in this case, the sample variance or standard deviation, if you're given them, you don't have to do any work to find them. Round to the same decimal place as the data you're given. Those are just our general rules of thumb. Those really haven't changed since we started working with mean and variance and standard deviation back in chapter 3. Those rules haven't changed. I know with probability that we worked with in chapters 4 and 5, I know we had some different rounding rules with probability in some of our distributions, but when we're working with just our population or sample, just our measures, these are our basic rounding rules. They're not going to change for us. Okay? So let's take a look just at one example together. We're going to take a look on page 404, and we're going to take a peek at question 10. We're going to use table G. We'll walk through how to find chi-square right and left, and we'll also use the formula, which again is inconveniently on the other side of your sheet. Okay, so let's take a look. Page 404, number 10. Here we go. So we have a random sample of stock prices per share in dollars is shown. Find the 90% confidence interval for the variance and standard deviation for the prices. Assume the variable is normally distributed. So this one, I chose this question for a couple reasons. First of all, it's bringing back that idea of raw data. And I also wanted to make sure we're bringing back that idea of, I use my calculator to find which thing do I get. Do I get the sample variance? Do I get the sample standard deviation? What does the calculator tell me? Which option do I choose from the calculator? So if you have your calculator handy, let's take a minute. Let's get the data in number 10 entered in. I'm going to enter it in on mine too, because mine, of course, restarted, so it's not happy with me right now. So I'm going to go ahead and get mine entered in as well for you. So stat and edit. Here we go. And I know they're not super convenient because they're decimals, but I also wanted to bring up the idea of those rounding rules too, because I have some people that think if it's raw data, I just go to the nearest tenths. And that is not the rounding rule. So I want to make sure we revisit that too. So this example is going to get us a lot today. All right, I'm on my last row, guys. Bear with me here. I had them set, but then my computer decided to restart itself. So, oops. 0.75. Oops, not 4.75. 14.75. Okay. So we do some stats. We do some calc. One of our stats. All right, so here's the information that I'm given. If we look at our formula, I don't need x bar. First couple sections of chapter 7, we needed x bar. That was really what we were taking from this. If we didn't know the population standard deviation, we did need our S also. So if we look at our formula, what piece do we need to pull from this? We need the S. We need the S. And it's kind of nice that the symbol's right there in our formula of what we need to take. And we need the S. Now the question is though, what do we round the S to?
3 decimal places.
3 decimal places. Raw data does not mean, oh, I just round to the nearest tenths. I think in a couple of the examples we came across, we kept rounding to the nearest tenths because our data was whole numbers. Our raw data is to the nearest cent. It's to the nearest hundredths. So I need to go one more decimal place, so we should actually take it to 3 decimal places. And we need the S. Keep in mind we need the S. So let's go ahead. Let me switch back here. We need the S. All right, so S. Maybe. There we go. So S is approximately, it was 20 point something, 284. So again, we went 3 decimal places because the raw data went to the nearest hundredths, or that second decimal place. All right, there's our S that we need. We also need our sample size. Our sample size is what? It's 20. Just count how many values you have. Sample size is 20. Now, the other pieces we need for the formula, we need chi-square right, we need chi-square left. So in order to do that, we've got to go to table G. So I'm going to bring up table G. If you need to, it's 791 in your book. Otherwise, I did give you guys that handout earlier. All right, so in table G, here we go. If we follow our steps, it says we need to find our alpha over 2. So if we have 90% confidence, what's our alpha over 2 going to be? It's going to be 0.05. Oh, hang on, let me switch colors. I have bright green. That's not going to work. Okay, so we had our alpha over 2 is going to be 0.05. Our confidence level is 90%. So it means our alpha is going to be our 10%. And we have to divide it by 2. So alpha over 2 is 0.05. So that's going to get us the value on the right side of our table for chi-square right. I do 1 minus that, and it's going to get me the column I need for chi-square left. So this is alpha over 2. This is 1 minus alpha over 2. Oop, that's a really bad alpha. There we go. Not much better. All right, so 1 minus alpha over 2 will get us our column we need to find chi-square left. Now, the actual row we need is linked to our degrees of freedom. Our sample size was 20, so degrees of freedom will be 19. All right, so here's the row we're following. There's our column. Here's our other column. The value that's on the right side of your table is chi-square right, so 30.144. The value that's on the left, they're named according to which side they're falling on. So the value that's on the left is chi-square left, so the 10.117. Now the process we did of finding alpha over 2 and doing the 1 minus, that is on the front side of your note sheet. That process is on there. So when you go to do your own practice, if you're like, wait, what did we do? I don't remember. I've got that process on there for you. So let's go ahead and get our information down. Let's take a peek into the formula and let's get you guys some time to work. Some time to work with this table with me here to help. Okay, so chi-square right was 30.144. Chi-square left was 10.117. So now we have all the pieces. Remember, I always like to bring up for you guys those common areas of mistake that I see when it comes assessment time. So let's put some pieces in. I'll talk to you guys along the way here about those things. So we have n minus 1. Yes, I know 20 minus 1 is 19, but I'm not going to shortcut anything putting these pieces into the formula the first time. Now, the next part of my formula is an s squared. I only have s. So I'm going to put s into the formula, substitute in for s, and then I have to square it. I only know s. I do not know s squared. And I recommend if you only know s, I would substitute in like I did and then square it. I would not square it ahead of time and then put it in. That seems to confuse people. Substitute it in. Now, one of the big areas of mistakes that I see on the test when it comes to this particular interval is we're putting chi-square left and right on the wrong side. Chi-square right actually goes on the left side of the interval. Anybody know why? Why would we put chi-square right over on the left? Because when I divide by that bigger number, chi-square right's bigger than chi-square left. So when I divide by a bigger number, I get the smaller end of our interval. When I divide by 30.144, I'm going to get a smaller number than when I divide by 10.117. The smaller number, the minimum amount for my interval needs to be on the left. You can put the bigger number if you want on the left, but then you have to make sure you change your inequality symbols to match. So go ahead and try entering these things into your calculator, making sure we get the right order of operations that we need. Try it out. You should get, and again, we're keeping with rounding to the nearest thousandths. This formula is not super complicated. There's not a lot going on in it. But I always find that the formulas that involve some type of fraction piece is where I see those computation mistakes, just because of how we entered in our calculator. So take a minute, make sure that that piece is okay for you. Again, there's not a magic. We're not going to go to stat and test and find a magic number program in there that's going to do this for us. It's not going to. The calculator's not going to have this for us. Now, based on your symbols, this is your 90% confidence interval for the population variance. Make sure part of your assessment when it comes that time, you have to have the correct symbol at the middle of your interval. You have to know what your interval is representing. If you don't have the correct symbol there, that makes me think that you're not sure what that interval even means. And you don't if you don't have the right symbol there. You're not sure what it's representing. Now, if I want to find, it also asks us to find the confidence interval for the standard deviation. I just have to take the square root of both sides. You just have to take the square root of both sides is all you have to do. Now, if you know you need to find both, what you can do is you can leave the left side in your calculator, write it down for the variance. While it's still in your calculator, just go ahead and take the square root, even before you round or anything. Just might make it a little easier. Might make it just a touch easier for you. Again, with the symbols, population, standard deviation. So these confidence intervals are saying we are 90% confident that the mean, the population mean stock price per share is somewhere between those two values. We're 90% confident that the population variance of stock prices is somewhere between those two values. We're 90% confident that the population standard deviation of stock prices is somewhere between the 16.104 and the 27.797. This is our confidence interval for variance and for standard deviation. You won't always be asked for both, so make sure you read the question carefully. If you're only asked for one, let's say come test time, if you're only asked for one and you give me both, you will lose points. Again, you just have to make sure you're finding what's necessary. It doesn't always take both of these. I wanted to do an example with both so you could see both of them. Okay? So I want to give you guys some time. Your assignment is on your sheet. And there is, again, just a reminder, there is no technology for this section.